At this hour, when the house is quiet and the screens have finally gone dark, I like to imagine one last glow still awake far above us. A small visitor drifting through the dark between the stars. They named it 3I Atlas, the third known traveller from another system, but names are just labels. What matters is how strangely it behaves compared with the sleepy comets we thought we understood. Most comets grow active slowly, like a kettle warming on a stove, hissing a little louder each minute. This one stayed almost silent on the way in, and then, right around its closest brush with the sun, it changed character in a rush, sprouting jets in many directions, shifting colour, and responding to forces we still do not fully see. Astronomers pointed radio dishes at it, and, after weeks of quiet, finally heard a faint signature from simple molecules slipping off its surface, like a whispered note in a vast concert hall. You may have heard the official comfort. It is just another comet, they say, doing comet things. You may also have heard the more restless voices asking why its path needed extra corrections, why some images and measurements have been slow to appear, why this visitor seems to wake up all at once instead of yawning into activity. Tonight, we will not chase drama or headlines. We will simply walk, step by slow step, through what has actually been seen, how comets normally behave, and where this one seems to lean away from the script, always returning to the same gentle truth. It is allowed to be mysterious, while you are allowed to rest. So let the day loosen its grip a little, breathe out, and let this quiet, interstellar story keep watch for a while as you drift. If you let your eyes grow soft for a moment, you can picture it very simply. A small knot of light against a darker ocean, barely brighter than the background stars. I imagine us standing beside a quiet telescope somewhere in the high desert, the air thin and cold, the dome slit open like a careful eyelid. On the screen in front of us, 3I Atlas is nothing like the dramatic posters you see of famous comets. There is no huge sweeping tail yet, no loud display, only a compact glow and a faint smear of light trailing away from the sun. In that first impression, it almost behaves, almost agrees to look like the comet category we tried to place it in. At the center of that blur is the nucleus, far too small to resolve directly, hidden inside a cloud of gas and dust. Around it, the coma is a lantern haze, sunlight bouncing off tiny grains that have been lifted free. Most comets, seen in this way, follow a simple script. A bright head, a tail stretched away from the sun like hair in a steady wind. If you draw an arrow from the sun to the comet, the tail almost always points in the opposite direction. It is one of the gentlest rules in the sky, a rule written by light and charged particles and nothing more. Later, when 3I Atlas had swung past its closest point to the sun, those images began to change. The smooth smear behind it broke into strands, thin rays of brightness pointing in slightly different directions, as if the lantern haze had grown filaments. You could trace one jet along the expected path, away from the sun, and feel a little relief. Then another would appear at an angle, leaning sideways into space instead of cleaning up nicely behind the object. Soon, the neat picture of head plus tail gave way to something more tangled, like a halo, that did not want to stay uniform. I remember staring at processed frames where each jet was enhanced to stand out from the background grain. One ray streamed roughly away from the sun, another leaned off to the side, and a third seemed to hook back toward the light source itself. comet scientists are used to jets. They are not surprising by themselves, because frozen ices do not melt evenly. They crack, they vent, they carve narrow fountains from certain patches of surface where the sun can reach more deeply. Here, though, the layout felt different, like strands of brightness stitched into a pattern instead of random splashes. On one set of observations, a particularly bright feature was described as sunward, a jet that appeared to bend back in the direction of the star. Tails are supposed to be pushed away, remade constantly by the outward flow of particles streaming from the sun. A jet that seems to turn toward that source suggests something more complicated than simple sunshine carving ice. It might be material thrown off the night side, the cooler face of the object, with enough speed that its path arcs into the light. It might also be an illusion of perspective, our line of sight turning a three-dimensional fountain into a two-dimensional curve on the screen. In the control rooms where these images arrive, nobody jumps up shouting about engines. Astronomers start with the basics. They ask how fast the object spins, where the patches of darker and lighter material might sit, how deep the cracks run. A nucleus that rotates can bring hidden regions into sunlight, switching different vents on and off like lamps in a hallway. If the interior holds reservoirs of gas at different depths, some may wake early, some late, some only after the surface has been stressed by the heat of perihelion. Piece by piece, the puzzle is tested against that ordinary physics, not because people lack imagination, but because gravity and sunlight have earned the right to be asked first. When I look at 3i Atlas in my mind now, I do not see a sleek spacecraft. I see a lumpy shard wrapped in this restless glow of jets and faint streamers. The quiet halo around a visitor changes shape, night after night, yet the core remains an unresolved point, a stubborn little pixel of brightness at the center. Every new image adds another thin line to the sketch, another hint of where gas may be escaping, another clue about how the surface is arranged. None of those lines, by themselves, prove anything exotic, yet together they whisper that this object prefers to express itself in many directions at once. That is unusual for a comet, but unusual does not have to mean impossible. You can think of each jet as a controlled leak, and each leak as a tiny push. When gas escapes, it carries momentum, and the object reacts by moving ever so slightly in the opposite direction. Millions of tiny pushes, sustained over days and weeks, can add up to a measurable nudge in the orbit, even if the surrounding coma never looks enormous to the human eye. An observer might see only a modest cloud and a handful of bright streaks, while the trajectory silently accumulates the effect of those patient, invisible shoves. In that sense, jet structure and path are part of the same slow conversation between the visitor and the light that bathes it. Some researchers have noted that 3i Atlas appears to get more interesting after its closest approach to the sun, not before it, as if it needed that intense moment of heating to unlock new vents. Others focus on how calm it looked earlier on, how late these complicated patterns arrived, how abrupt the change feels when you lay the images side by side. If you line up those frames like lantern slides and flip through them gently, you can almost watch the halo rearrange itself in time. There is a sense of intention in any pattern that develops, but intention is a feeling our brains are very good at projecting onto natural systems that follow quiet rules. The task of science here is to keep the feeling, but separate it from the conclusion, to keep wonder without skipping ahead. Down at ground level, where you are lying in the half-dark listening, none of this demands alarm. A knot of ice and rock from another system is shedding gas in complex ways under the touch of our star. The jets help us estimate spin, composition, and internal structure. They let us refine the path and test our models of how such visitors behave. At the same time, they give us permission to admit that we have not seen every possible version of a comet before, that the universe can still improvise within its own rules. While you breathe in and out, the object keeps tracing its path, its faint lamps of gas turning on and fading again, and the sky above you holds that small mystery with a soft, unhurried hush. Imagine that you are no longer looking through glass, but listening through a metal ear spread wide under the southern sky. In South Africa, far from bright city lights, the MeerKAT radio telescope lies as a field of dishes, each one shaped like a quiet question tilted up toward space. For a moment, we will let the story be told from that steel and circuitry point of view. You are one dish in that array, your curved surface cooling under the stars, your motors making tiny adjustments as software steers you toward a moving point in the sky. Most of what washes over you is familiar static, a soft hiss made of distant hydrogen, background galaxies, and the steady afterglow of the early universe. Buried inside that hiss are narrow lines, little dips and peaks at very specific frequencies that tell you which atoms and molecules are out there breathing in the dark. Tonight, your target is 3E Atlas, not as a dot of light, but as a possible absorber of radio waves at 2 precise tones, just above 1.5 GHz. Earlier attempts did not go well. On a September night, you were pointed to the same patch of sky, tracking the visitor as it approached the sun, and nothing special happened. The spectrum rolled by, smooth and quiet, no deep notches where hydroxyl radicals would have bitten into the background signal. A week later, another try brought the same answer, just that gentle, featureless hiss. Then October came, and with it, a closer pass to the sun and a hotter, more stressed surface on the interstellar object. On the 24th, the array settled once more onto the coordinates of 3E Atlas, integrating signal over long minutes the way you might hold your breath to hear a faint sound in another room. This time, when the spectrum appeared on the screen, there were 2 tiny valleys at exactly the right places, at about 1.665 and 1.667 GHz. They were not dramatic to the casual eye, just narrow dips in a landscape of noise, but to the teams who had been waiting, they were as clear as a low note appearing in a song. Hydroxyl radicals were there at last, fragments of water molecules broken apart by sunlight, and now marking their presence by the way they removed certain radio tones from the background wash. From your point of view, as the dish, it was a small change in voltage, a slightly different pattern of wiggles in the data stream. From the human point of view, it meant the comet-like traveller had finally begun to release enough gas for radio astronomy to catch it in the act. Nothing like a deliberate transmission was seen, no pulsed beacon, no repeating code, just that soft pair of absorption lines where none had appeared weeks before. To many scientists, that timing was simply the moment when the surface woke up, when ice that had stayed stubbornly frozen finally cracked and vented under the new heat. To others, There was something eerie about how sharply the switch seemed to flip, like a room that stays dark for hours and then lights all at once. In the analysis that followed, those two little dips were measured in detail. Their depth, their width, even the slight broadening that comes from motion and temperature, all carried information about the state of the gas. The numbers pointed to a surprisingly low average temperature, barely more than 230 degrees above absolute zero, as if the surface were only reluctantly beginning to thaw. The narrowness of the lines suggested that the molecules weren't being blasted off in violent explosive jets in every direction. Instead, they seemed to be seeping out in a more controlled flow, like steam easing from a valve rather than bursting from a broken pipe. When you listen long enough, you learn that space is full of such nuances. A line that is wide and messy hints at chaos. A line that is thin whispers of gentler motions. The MeerKAT detection of 3I Atlas fell into that second category, and so conversations turned to the puzzle of why the object had been so quiet for so long. Was there a thick crust of dust or processed material on top, insulating the deeper ice until pressure and heat finally overcame it near perihelion? Or had we caught a rare geometry and timing where most of the earlier gas release simply escaped in directions that made it harder to see? Radio astronomers are used to waiting years for signals that last only seconds, so a few weeks between attempts is not a hardship. In a way, that rhythm mirrors your own breathing tonight, long stretches of silence punctuated by brief, meaningful events. The first faint note from 3I Atlas was not loud enough to wake the world, but it was loud enough to change the questions on the whiteboards. Models had to be updated to include a dormant inbound leg and a sharper turn on near the sun. Expectations about when similar objects might wake on future passes through other systems stretched to include this late blooming behavior. No one could say for certain whether this delay came from structure, composition, history, or coincidence. They could only say that by October 24th, the visitor was finally speaking in molecules instead of silence, and the instruments had been patient enough to hear it. In control rooms, people leaned back slightly in their chairs, satisfied not in having solved the mystery, but in having captured a clean, solid piece of it. You can picture the screens dimming later that night, windows reflecting the glow of monitors as they are put to sleep one by one. Outside, the dishes keep their quiet stance under the stars, still listening to the cosmic hum, that new low note from 3 Atlas, now folded gently into the song. You might be wondering, lying there in the dark, why any of this matters. Why do astronomers care so much about whether a comet wakes up gently over months or suddenly in a few days? Why does the timing of a little gas release around perihelion matter to people who could be sleeping instead of staring at graphs? Let me answer you slowly. Imagine you're watching a traveller on a long train journey across a continent. Most passengers stretch, talk, and shuffle about long before the final stop, their movement building up gradually as the trip nears its end. But one person sits almost perfectly still for the entire ride, eyes closed, hands folded, giving no sign that they are even awake. Only when the train slides into the last station do they stand, speak, and gather their things in one deliberate motion. The traveller who only speaks at the last station. 3I Atlas has behaved a little like that quiet passenger. For months on the inbound path toward the Sun, telescopes watched it, with the expectation that activity would slowly ramp up. Normally, as a comet draws nearer, more sunlight reaches its surface, more ice sublimates, and the surrounding coma and tail grow steadily brighter. There is a sense of rehearsal in the usual pattern, a soft crescendo. Yet, for this interstellar visitor, the music stayed faint, much longer than expected. You might ask, did we simply miss the early notes? Perhaps the instruments were not sensitive enough, or the scheduling windows too brief, or the geometry just unlucky. Those are fair questions, and researchers ask them too, going back over observation logs and exposure times to see whether subtle signs had been overlooked. In many cases, the data show a consistent story. The inbound phase was unusually subdued, with little obvious outgassing compared to what similar distances have triggered in other comets. Then, as you heard from the radio side of the story, something changed close to perihelion. Hydroxyl absorption lines that had been absent in September appeared sharply in late October. Images that once showed a modest coma and a simple tail began to reveal more structure, the start of those complex jets. Color measurements shifted from warmer red tones toward deeper blue-green hues, hinting at different gases or particle sizes entering the mix. It was as if the traveler, silent through most of the route, finally rose and cleared their throat in a single, unmistakable gesture. So you may wonder, can a comet really wait that long? Does ice not respond gradually as the heat increases? The answer is that under many conditions, it does. But comets are not perfect snowballs. They are layered, crusted, and cracked in ways that can delay or localize their response. Think of a thick, dusty rind sitting above cleaner ice, a kind of insulating blanket that keeps the deeper material cold even as the outer skin warms. Sunlight may bake that outer layer for weeks, but until fractures open or pressure builds enough to break through, very little gas escapes into space. In that picture, the late wake-up is not magic, it is mechanics. Gas produced in the deeper layers migrates along narrow channels, squeezing through pores and weaknesses in the crust. Pressure mounts slowly behind patches of material that have been hardened by eons of radiation in interstellar space. Eventually, near perihelion, the combined stress of heat and internal gas is enough to crack the shell in several places, almost at once. From a distance, that would look like a quiet object, suddenly growing jets, tail changes, and radio signatures all in a short span of days. You might ask next, is this behavior normal for interstellar objects? Or is 3i Atlas just odd even among its peers? The truth is that our sample size is tiny. We have only a couple of previous interstellar visitors to compare against, and each one has told a slightly different story. Some have shown non-gravitational accelerations without an obvious coma. Others have behaved more like standard comets from our own cloud of debris. With so few examples, it is no surprise that a late waking traveler feels like it breaks the pattern, when, in reality, the pattern is still being drawn. Another question that often floats up is whether a sudden activation like this must mean something artificial. If natural comets usually warm gradually, does a sharp switch imply some kind of mechanism? Here it helps to remember that sharpness is often in the eye of the beholder. From our vantage, we see snapshots, discrete nights of data separated by gaps, and our brains connect those points into a step instead of a slope. Up close, on the surface itself, The transition from quiet to active may have been more continuous, just concentrated into regions and times we did not sample well. There is also the matter of how long this traveller has been cold. An object wandering between stars for millions or billions of years experience temperatures just a few degrees above absolute zero. Under those conditions, ice can become incredibly rigid and glassy, and dust can fuse into a protective shell that does not respond quickly to gentle warming. When sunlight finally returns in a new system, it may take more energy to disturb that ancient structure than it does for comets that have cycled many times around our own sun. In that sense, a delayed outgassing phase could be a natural consequence of deep time, not a sign of hidden engines. As you let your thoughts slow, it may help to picture 3I Atlas not as a scheming object, but as a piece of frozen history. It carries layers written in another star's youth, modified by radiation in dark space, then nudged into our neighborhood for a brief encounter. Its reluctance to speak until the last station is part of that history, a reminder that we are still learning how such travelers keep their secrets. The late burst of gas, the sudden appearance of spectral lines, the complex jets emerging near perihelion, all become clues folded into a longer journey we only glimpse at one stop. In the end, delayed activity is a question of timing, not threat. The object obeys gravity, obeys energy, obeys the same physics that guide every comet and asteroid we have ever studied. Its differences help refine the models, stretch our expectations, and enrich the catalogue of what comets can do when conditions are just so. While astronomers adjust their equations and schedule more observations, you are allowed to simply let the story wash over you like a slowly retreating tide. The traveller has spoken at the station it chose. Now its voice fades back into the general murmur of the solar system, and the night around you grows a little quieter again. Some nights in astronomy feel like postcards you could send to your future self. A date, a thin line of ink on a chart, a quiet note in the margin that says, "This is when something small but important changed." For 3I Atlas, one of those postcards was written high in the Atacama Desert, where the air is so dry it feels as if the ocean has been lifted straight off the earth and poured into the sky. In that thin air, the dishes of the array sit like patient ships in a stone harbour, listening and looking not for waves of water, but for the tiniest shifts in where a distant visitor appears each night. Before the observations, the path of the object was a neat curve, drawn on virtual star charts. Its orbit had been calculated from many earlier positions, all consistent with a small body falling freely under the pull of the sun and planets. Think of a sea lane traced on a map, a route that a ship should follow if currents and winds behave as expected. When the array locked onto 3I Atlas after perihelion, astronomers compared where the ship was supposed to be with where it actually showed up, the way a navigator might glance from compass to horizon. The difference was just 4 arc seconds, a sliver of angle so small it would barely separate 2 stars to the naked eye. Yet, in this context, it mattered. An arcsecond is 1/3600th of a degree. On the sky, that seems almost laughably tiny. But when your ship is millions of kilometers away, even that small tilt translates into a real lateral shift, like finding that a vessel in mid-ocean is now dozens or hundreds of kilometers off its plotted course. The instruments had been precise, the timing careful, the calculations checked and rechecked, and still the visitor sat those few arc seconds away from the promised place. In the language of orbital mechanics, that is not a smudge on the glass. It is a signal that something besides gravity has nudged the hull. For comets, such nudges are not unheard of. As they warm, jets of gas erupt from their surfaces, throwing off material that acts like faint but persistent thrusters. Each jet is a small puff of exhaust, and each puff pushes back on the nucleus, altering its speed or direction just enough that, over weeks, the path must be updated. When you trace this on a chart, the ideal gravity-only line becomes a kind of reference route, while the real object follows a slightly shifted track that reflects its own ongoing outgassing. In ocean terms, the difference is like the drift caused by a crosswind, subtle at first, then noticeable when you check your position against the stars. With 3i Atlas, though, there was a twist that drew more attention than usual. To produce the measured non-gravitational acceleration implied by those 4 arc seconds, the jets would have to be doing more work than the visible coma seemed to justify. If a ship has engines running hard, you expect to see a wide wake spreading out behind it, foam and churn marking all that spent energy. Here, observers saw a relatively modest cloud of gas and dust, a traveller whose visible wake did not look dramatic enough to explain the shift in course. The halo was there, the jets were there, but the scale of the push inferred from the orbit felt large, compared with the quiet appearance of the surrounding sea. This mismatch between path and wake is what led some researchers to speak cautiously of alternative possibilities. One well-known astrophysicist suggested that if no large, dense coma could be found to account for the acceleration, then the door might remain slightly open to a more engineered explanation. He did not declare that the ship was powered by engines or guided by intent. Instead, he phrased it as a testable criterion. If future observations continued to show significant course changes without corresponding outgassing, then, and only then, would it be reasonable to treat the behavior as a possible technological signature rather than just an odd natural one. Framed that way, the idea became less a headline and more a conditional note scribbled in pencil on the edge of the nautical chart. Most of the community, meanwhile, kept working within the familiar currents. They explored models where gas might vent through narrow, hidden channels, producing thrust without inflating a huge visible coma. They considered the role of rotation, where jets from certain long-lived vents could act like steady side winds, pushing more efficiently in one direction. They examined how sensitive the orbit fits were to observational uncertainties, making sure they were not mistaking a slight mismeasurement for a physical push. Piece by piece, the effort was less about proving something exotic, and more about making sure the known physics had been thoroughly asked what it could do. For you, listening now, it can be enough to picture a small ship on a very dark sea, following a route that astronomers have charted as best they can. Each new observation is like a fresh position check, a pair of coordinates transmitted back to the harbour. When the latest postcard arrives and the mark is a little off the inked line, nobody panics, but nobody shrugs either. They draw a new curve that fits both gravity and the accumulated pushes from unseen jets, then send the ship's updated route out to every other watcher along the coast. In this way, the entire network of observers stays in quiet agreement about where the visitor is and where it is going next. All through this, one thing remains steady. The object is not on a collision course with Earth. Its altered path still threads safely through the inner system, a distant pass more akin to a ship gliding along the outer edge of a bay than one bearing down on the shore. The puzzle here is not about danger, but about mechanism, about how much invisible thrust nature can hide in a modest-looking coma. From the standpoint of nightly life on our planet, nothing in your sky routine needs to change. The ocean of space is vast, the ship is far away, and the only waves that reach you are the gentle ones of curiosity running through your thoughts. When the Atacama observations for that night were finished, computers saved the new positions, graphs updated with the fresh curve, and the control room lights dimmed one notch lower. Outside, the array sat under the same familiar stars, their antennas like lanterns turned down but not out, still ready to listen and look. If you could turn that moment into an actual postcard, it might show a faint dot just off a drawn line with a handwritten note saying the ship drifted a little, and now we know it. Then the image would fade softly, like a deck lamp lowered at the end of a calm watch, and the great dark sea overhead would go on, holding both the line and the ship in its quiet, steady arms. On some nights I close my eyes and try to hear a picture before I see it. The low murmur of a control room, the faint hum of cooling fans, the soft click of keys as images of 3i Atlas refresh on the screens. Behind those quiet sounds there is another layer, the imagined rustle of colour changing, as if the sky itself were slowly pulling one fabric down and lifting another into place. At first, the object wears a dull, reddish cloak, the kind of tone we have learned to expect from dust darkened by long exposure to space. Then, week by week, the cloak begins to shift toward blue-green, threads of different light woven into the pattern until our instruments insist that the colour has genuinely changed. Early observations showed the visitor as slightly redder than the background stars. That is usually a simple story. Dust grains on the surface and in the coma scatter sunlight in a way that favours longer wavelengths, leaving the reflected light tinged like old brick or rust. Many comets from our own system look this way when they are far from the sun, wrapped in a coat that has been stitched together by organic compounds and fine particles. With 3i Atlas, that initial palette reassured observers. Nothing about its first appearance screamed for a new category. It fit neatly into the shelf where we file cold, distant, and dusty. Closer in, as the sun's energy began to work more strongly on the surface, photometry told a more unusual tale. The broad colour index shifted, first toward a more neutral tone, and then into a range that implied bluer light, contributing more than before. In practical terms, that meant filters sensitive to shorter wavelengths started to pick up proportionally more signal, an indication that either the dust size distribution was changing or new glowing gases were joining the scene. It was as if the cloak were being unpicked from the inside, darker threads loosening, finer filaments of turquoise and aquamarine being woven through the older fabric. For an interstellar object expected to grow dustier and redder, that reverse drift stood out. One natural explanation starts with very small particles. When grains become tiny compared with the wavelength of light, they scatter shorter wavelengths more efficiently, in a way that subtly favours blue. If the activity near perihelion began grinding material into finer dust, or liberating microscopic fragments from fresher layers. The net effect could be a tightening of the weave toward the blue end of the spectrum. In that picture, the cloth of the coma is literally being rewoven with different thread sizes as 3I Atlas warms. The overall brightness might not skyrocket, yet the balance of hues would shift as the new pattern takes over from the old. Another line of thought focuses on gas rather than dust. Certain molecules, when excited by sunlight, emit light at characteristic bands that fall in the blue-green part of the visible range. Cyanogen and simple carbon chains are famous for this, painting many comets with a ghostly glow when they become abundant around the nucleus. If 3I Atlas began releasing more of these species near and after perihelion, their emissions could lay a luminous veil over the existing dust reflection. In spectral plots, those contributions show up as distinct features. In more basic images, they simply tint the cloak, lending the visitor a new color identity. From the ground, most observers never see the raw spectrum. They see processed images and color composites that represent all of this physics as a single shade. For them, the story becomes a simple but striking sentence. The comet that was once red now appears deep blue-green. In the quiet of the lab, though, the nuance returns. People talk about band strengths, filter responses, calibration stars, and the care needed to be sure the change is real and not an artifact of instruments or processing. Only when those checks are satisfied does everyone agree that the cloth has genuinely been reworked rather than merely mismeasured. You may notice how easily the human mind jumps from a change in color to a change in meaning. Red invites one set of associations, blue suggests another. It is tempting to see the cloak shift and imagine intention, as if the visitor had chosen to dress differently for its pass by our sun. From a scientific standpoint, though, the change is a clue, not a costume choice. And the clue points us back to chemistry, grain size, and the depth of the layers being disturbed. Even so, there is a quiet poetry in watching a distant object alter the very fabric of light it returns to us. In the deeper halves of the control rooms, where specialists compare early and late data, conversation turns to what this means for the object's history. A cloak that reddens over many orbits suggests surface material that has been processed again and again by sunlight and cosmic rays. A cloak that suddenly brightens in blue might hint at fresher reservoirs being exposed, seams in the fabric where older, darker layers are torn open to reveal cleaner ice and gas from within. Because 3I Atlas comes from beyond our system, its internal pattern may have been set long before our sun ever formed. Each change in color now is like a loose thread we can tug to learn how that distant weaving was first done. Deep in the second half of the night, plots of color indices and spectra accumulate in directories with quiet names and timestamps. Someone scrolls through them slowly, watching the numerical representation of hue slide across a calibrated scale, frame by frame. The shift is not chaotic. It follows the object's distance from the sun, its evolving activity, and the composition of what is being shed from its surface. Yet, it still surprises those who were expecting a steadier, redder cloak throughout. In one particularly dense stretch of data, the numbers trace a smooth curve toward bluer values as perihelion approaches, then linger in that region longer than some thermal models would suggest, as if the newly woven fabric resists fading back to its old pattern even as the object moves away. When tired eyes finally step back from those screens, the scene quiets to a kind of telemetry idle, a low, steady stream of numbers still arriving, but changing more slowly, like a loom that has begun to slow its shuttle. The object continues to spin and shed, but the most dramatic adjustment to its visible cloth seems to have already taken place. Future nights will tell whether the cloak gradually returns to warmer tones or stays marked by the blue threads that perihelion pulled through it. Either way, nothing in this play of colour threatens the earth below. It is simply another layer in the tapestry of how an interstellar visitor responds to our star. You can let that image settle over you now, a small body far away, its cosmic garments subtly rewritten by heat and chemistry, while your own room stays wrapped in the familiar fabrics of blankets and shadows. If we could drift a little closer to 3 Atlas, just for a moment in thought, I imagine starting with a very small detail, a patch of surface no larger than a room. In my mind, it is not smooth. It is pitted and rough, with tiny shadows clinging to each hollow the way mist gathers in the grooves of old stone. Some spots might glint more than others, tiny flashes hidden under the dust, hints of something denser and more metallic beneath the outer frost. We do not have images sharp enough to confirm this picture, but the measurements we do have suggest a body whose bones could be richer in metal than those of a typical comet. From Earth, we never see the skeleton directly. We work with reflected light, with how the object responds to heat, with how strongly it reacts to the sun's pull compared with its size. Those clues, combined with comparisons to other small bodies, have led some teams to propose that nickel and similar heavy elements may be unusually abundant inside this traveller. If that is true, then beneath the dusty rind, the nucleus might be more like a compact ingot than a loose rubble pile, a condensed core that has held its shape, while lighter material has been shaved away. In that sense, the dust and ice we see now would be just a thin veil over something tougher, like vapour, drifting over a buried bar of metal. Nickel and iron are not exotic in themselves. They are common products of stellar furnaces, forged in the hearts of massive stars and scattered when those stars die. On young planets, these heavy elements tend to sink inward as the body melts and differentiates, forming dense cores wrapped in lighter mantles and crusts. When such worlds are shattered by collisions, fragments of their innermost regions can be flung into space, cooling into metallic shards that wander for eons. We find such pieces in our own backyard as iron meteorites, visitors that ring on impact and reveal polished, crystalline patterns when cut and etched. So one picture of 3I Atlas is that of a core fragment from another system, a piece knocked loose from a world we will never see. In that view, it is a shard of an ancient planet's heart, stripped of most of its original cloak and left to wander through the galaxy inside a faint haze of ages. Over millions and then billions of years, thin layers of ice and dust could have condensed or accreted on its surface as it passed through different regions of interstellar material. Each encounter would leave a slight residue, a new skin over the same dense interior. By the time it reached our sun, the original violence that sent it out would be long buried under that quiet outer mist. The age estimate that has been discussed for this object, around 7 billion years, adds to that sense of deep time. It doesn't come from carving a date into the rock, but from running its motion backward through models of how stars and gas move in our galaxy. When researchers trace its path through the swirl of the Milky Way, they find that it likely came from a region where stars formed long before our Sun, in an older neighborhood of the disk. That conclusion carries uncertainties, because orbits through a changing galactic potential are hard to reconstruct exactly. Yet, the broad message is clear. This traveler may be older than our entire solar system. It has been moving through the thin, cold fog between stars for longer than complex life has existed on Earth. Think about what that timescale means for the surface. For billions of years, cosmic rays have been striking it, breaking molecular bonds and slowly turning the outermost layers into a processed, compacted crust. Tiny dust grains flying through space at high speed have peppered it with microscopic craters, each one another small disturbance in the outer mist. Where ice was once clean, it may now be chemically darkened, its structure altered by radiation and repeated impacts. Where metal was once bright, it may now be coated by a thin film of altered material, the way fog can leave a fine deposit on glass over many damp nights. In that context, the late awakening we talked about earlier becomes easier to imagine. A body that has been hardened for billions of years will not yield easily when it first feels the warmth of a new star. Its crust can act like a shell, resisting the release of gas until heat penetrates deep enough or internal stresses crack the surface along old lines of weakness. Only then does the trapped volatility seep out, lifting dust and changing the color of the surrounding haze. What looks, from our brief vantage point, like a sudden shift, may be the delayed response of a structure that has been locked in place for unimaginably long. The possibility of high nickel content has drawn attention for another reason as well. If you wanted to build something to survive a journey between stars, you might choose materials very much like the ones nature uses for planetary cores. Nickel-iron alloys are strong, resistant to many forms of damage, and able to hold together under extreme cold and radiation. It is not unreasonable to say that an engineered probe could share some properties with a natural core fragment, including density and composition. That overlap is precisely why scientists have to tread so carefully. The same clues that make an artificial scenario seem practical also make the natural scenario entirely plausible. Sitting here, far from the object, I find it calming to remember that we do not have to decide between those possibilities tonight. Our instruments have suggested a tough interior, perhaps richer in metal than typical cometary nuclei, and models of its path hint at an origin in an older stellar population. These are pieces of a puzzle, not a verdict. The simplest explanation that fits them is still that of a natural fragment, a relic of planet building and planet breaking in some ancient system, whose light we now see only as part of the general glow of the galaxy. If future data demand a different story, we can update the picture, but we are not obliged to paint one now in sharper lines than the evidence allows. When I zoom my mind's eye all the way out, 3-eye Atlas shrinks from a close-up patch of rough surface to a tiny mote drifting through a galaxy-wide mist. Our sun is just one lamp in that haze, briefly illuminating the traveler as it passes. For a few months we catch the way its jets behave, the way its color shifts, the way its path bends a little under invisible forces. Then it will slip back into the dimmer regions, carrying its nickel bones and ancient scars away into distances where no telescope can follow. You, lying under your own ceiling of shadows, get to share this brief crossing with it, feeling not so much threatened as gently reminded of how much older and wider the universe is than any single worry that visits in the night. If light is the language of astronomy, then press releases are the subtitles we use to share it with everyone else. And sometimes those subtitles arrive with missing lines. As 3C Atlas grew stranger in our instruments, it also began to glow more brightly in the news cycle, where telescopes shared space with politics, and the quiet work of data reduction met the louder world of public expectation. I remember reading the official statement that tried to settle everything down. This is the third interstellar comet, nothing more, nothing less, behaving within the broad range of natural possibilities. If you only skimmed that message, you might have felt a gentle pat on the shoulder. Just a comet. Carry on. If you read it alongside the more detailed reports from observers, the picture grew more layered, like a lamp, with several shutters opening and closing at different speeds over the same sky. If a space agency speaks in calming tones while holding back some of the clearest images, people notice. They may not know the exact acronyms, but they understand delay. They understand we are still reviewing, and they sense when high-resolution frames remain behind an invisible curtain. In this story, that curtain hung over pictures from the Mars Reconnaissance Orbiter and other Mars missions during the object's close pass by the red planet. Requests for those images began to circulate not only in research groups, but also in the wider public conversation, sparked in part by familiar voices who are used to explaining the cosmos on television. If scientists on the outside are told to be patient while unusual behavior is discussed on the inside, a certain tension naturally builds. One well-known physicist spoke out more sharply than most, accusing the agency of unnecessary secrecy. His argument was simple. If the data show a boring, natural object, then release them and let everyone confirm that. If the data shows something genuinely puzzling, then many minds should be allowed to look, not just a few behind closed doors. He pointed to the missing Mars images, to gaps in the publicly available spectra, to timelines that did not match past practice for other comets and asteroids. If those delays were just the result of overworked teams and careful calibration, then transparency about that process could have softened the concern. Because that explanation was slow to arrive, the shutters in the public mind felt half closed, letting through enough light to see the outline of 3I Atlas, but not enough to study its finer features. A member of Congress added another beam to the scene by formally asking for a full release of the observational record. Her letter named specific instruments, specific dates, and specific data sets, especially those taken when the visitor skimmed within tens of millions of kilometers of Mars. If legislative attention turns toward a comet, you know that the story has stepped outside the usual scientific circle and into the broader arena where accountability becomes part of the conversation. On one level, those requests were about policy and procedure. On another, they were a reflection of something very human. The desire not to be the last to know when the universe does something unusual. In the shared sky above all of us, people want the shutters of information to open, not stay closed while a small group peers through the crack. All of this could sound dramatic, But inside the actual control rooms, the mood stayed quieter than the headlines. If an image is still being processed, the analysts on night shift simply keep working, comparing frames, checking calibrations, making sure that what looks like a strange feature is not a smear from a cosmic ray or a glitch in a sensor. If a spectrum shows an odd bump or dip, they run it against reference data and hardware logs before calling it real. There is nothing glamorous about these hours, only the soft glow of monitors and the slow scrolling of numbers. The distance between that calm and the louder arguments outside is itself a kind of contrast, like bright searchlights sweeping over a city, while, in one dim lab, a single desk lamp quietly illuminates a graph. Still, even in those calm rooms, people read the news during coffee breaks. They see the discussions about withheld data, about public figures asking whether something more than a comet is at play, about fans and skeptics trading theories in endless comment threads. If you work on the inside, that kind of noise can feel both encouraging and heavy at the same time. Encouraging, because it shows that the world cares about the sky. Heavy, because it reminds you how easily careful uncertainty can be mistaken for hiding something. So they keep checking their plots, keep refining their models, and keep nudging for broader releases, all while trying not to let the external glare distract from the gentle light of the actual data. From my own small vantage point, I find it helpful to run through a quiet set of if-then thoughts when the story feels tangled. If NASA and other agencies are moving slowly because they truly want to avoid mistakes, then the best thing we can do is give them time and keep asking clear, respectful questions about schedules and criteria. If, on the other hand, some images are delayed because they show features that are hard to explain, then releasing them to the global community of observers is the safest path, not the riskiest one, because many eyes can test many natural explanations at once. If some individuals leap straight to exotic conclusions, seeing intention in every jet and secrecy in every processing delay, then it is especially important for others to model a softer approach, open-minded but grounded, curious but not inflamed. In every case, the shared sky above us does not change. What changes is how fully we allow its light to pass through our own shutters of interpretation. One of the most comforting facts in all of this is that astronomy does not belong to any single institution. If one archive is slow, others can add new measurements. If one explanation dominates the press releases, alternative models can be published in papers, talks, and open data sets. Amateur astronomers with good telescopes can track the object themselves, confirming its position, its brightness, even some aspects of its changing tail and color. If anything truly dramatic were happening around 3i Atlas, it would have to pass not only through official channels, but also through this wide distributed mesh of independent observers. That mesh acts like another layer of shutters, this time controlled by thousands of hands instead of a few. As the weeks go on, arguments about transparency will rise and fade like distant flashes on the horizon. But the quiet work of watching the visitor will continue in many places at once. If more Mars data are released, and they show nothing unexpected, some of the louder suspicions will naturally dim, like a room growing darker after a bright advertisement fades from the screen. If those data contain genuine surprises, the conversation will shift toward understanding them, folding new light into our models rather than into anyone's agenda. Either way, the story of 3I Atlas will gradually move from the realm of speculation into the calmer territory of textbooks and review articles, where the lamps are steady and the shutters mostly stay open. For tonight, while discussions flicker on distant channels, your own room is governed by a much simpler control panel. A switch by the door, a glow from a screen, and the slow dimming of wakefulness as your thoughts grow softer. Somewhere far from here, banks of monitors in mission centers and observatories are already resting in a kind of electronic twilight. Status lights stay on, but the main displays have shifted to darker modes, waiting for the next observing window, the next stream of numbers, the next pass of the interstellar visitor through their fields of view. If you could stand in one of those rooms right now, you would hear only the background whir of machines and the occasional click of a keyboard as someone finishes a log entry. Then even those sounds would ease, consoles sliding towards sleep as staff step out into the night, leaving the sky itself to keep watch. In that shared darkness, the shutters over our questions are not fully closed, only tilted for the moment, until a little more light arrives. When a story starts to feel tangled, I like to reach for a handrail of simple facts and hold on while we walk, step by step, through what the object is actually doing. With 3I Atlas, those facts arrive as a sequence of images and measurements that, when lined up carefully, begin to sound like a quiet rhythm beneath the noise. The jets we first saw as isolated streaks haven't stayed frozen. They brighten, fade, shift, and sometimes vanish, like notes played in a slow, patient pattern. On one night, a jet flares on the sunward side, a narrow ray cutting across the coma at a particular angle measured in degrees from an imaginary north. A few nights later, that same position angle shows only a faint echo, while a different sector of the halo hosts a new streak, its brightness rising from the background like a fresh tone in the spectrum. If you plot these features on a polar chart, marking each jet by angle and distance from the nucleus, the result looks almost like the face of a clock, with certain positions lighting up more often than others. Each tick is an observation, each tick a data point that says, here, on this night, gas flowed more strongly from this patch of surface. Another set of observations focuses on time rather than position. The nucleus rotates, and that spin means any given vent spends part of its day facing the sun, and part of it turned away into local night. If a jet responds mainly to direct heating, its strength should rise and fall on that rotation schedule, like a fountain that plays only when the light hits the right side of the plaza. Teams have taken brightness measurements of individual jets and stacked them against the inferred spin period of the object, looking for peaks that line up at regular phases. Some features show exactly that behavior, a gentle swelling and fading that repeats each turn, reassuringly in step with a natural day-night cycle. Other jets are less cooperative. There are reports of features that seem to awaken when the relevant surface patch is just coming out of shadow, as if stored warmth from the previous sunlit interval is finally reaching subsurface ice. There are hints of activity on the night side itself, jets that should be quiet by simple heating logic, but nevertheless appear faint but persistent in images that capture the darker hemisphere. To make sense of these, researchers bring in thermal inertia, fracture networks, and pressure-driven flows, building models where gas produced in one region escapes somewhere else along buried channels. In such a model, the surface is not a smooth skin, but a cracked shell, with certain cracks acting as preferred outlets that fire slightly out of sync with the immediate sunlight above them. If you stand at a whiteboard with all of these measurements, you can start marking little ticks around a circle, each one tagged with a time and a brightness. Some clusters form where a vent is clearly tied to the rotation. Others scatter across faces in a way that is harder to assign to a simple schedule. Together, they produce a picture that is neither perfect order nor pure randomness, but something in between, like a metronome that keeps time while someone occasionally taps a different rhythm on the table beside it. Our ears are very good at hearing patterns in such layered clicking sounds. Our job here is to let the data show whether the pattern is real or just our attention grabbing the loudest beats. For a little while, I like to imagine the control room falling silent as everyone simply looks at one composite frame. Jets radiate from the nucleus like frozen strokes of chalk, some strong, some faded, some pointing toward the sun, some away, some leaning sideways in graceful arcs. The hum of computers softens into the background. The only motion is the slow blinking of status lights and the faint reflection of the image in a window pane. In that pause, there is no need to decide what the pattern means. There is only the simple act of seeing it clearly and letting your breathing fall into the same slow rhythm as the sequence of exposures that created it. When work resumes, the handrail of facts returns. Researchers count how many times each jet appears above a certain brightness threshold, how often it coincides with specific orientations relative to the sun, and how long it persists before fading below detection. They test whether events cluster more than random chance would allow, and whether those clusters line up with thermal models, stress maps, or possible subsurface pathways. Some early results suggest that a few vents behave like loyal instruments in an orchestra, playing on cue each rotation, while others resemble improvisers, coming in on offbeats triggered by deeper processes. The overall rhythm is complex, but complexity alone does not demand anything beyond physics acting through a rugged, ancient body. Of course, the same facts that support intricate natural models can be arranged into more dramatic narratives. If certain jets seem to fire when the object is at particular angles, not only to the sun, but also to Earth or to other bodies, it is tempting to imagine a form of regulated venting, as if something on or in the nucleus were choosing when and where to release gas. From a scientific standpoint, that phrase is best treated as a hypothesis on a very long list, one that will rise or fall based on whether future data reveal consistent, non-thermal triggers that cannot be explained by cracks, composition, or geometry. So far, patterns that look suggestive tend to soften when new points are added to the chart, melting back into the range of what a complicated, naturally fractured object can do under changing light. The metronome of rotation remains the main beat. The extra taps are still more easily traced to the messy acoustics of an uneven shell than to deliberate timing. In the end, what matters most for you trying to fall asleep is not which specific model wins, but how the process of testing those models unfolds. No single bright jet or odd timing will flip the verdict from comet-like traveler to controlled device. Instead, hundreds of clicks in the data will be compared, thousands of images stacked, and a slow consensus will emerge about which rhythms are solid and which were illusions of small sample sizes. That process takes patience, the same kind of patience your own thoughts can practice as you let them drift past without chasing each one. Far above, 3i Atlas keeps turning, its jets clicking on and off against the background of space, while down here the ship of our understanding slowly turns its starboard rail toward calmer water, letting speculation fade into the distance like a pattern of taps growing softer with every passing minute. There is a certain kind of night when the sky feels less like a ceiling and more like a map. Faint routes, traced between stars, old crossroads marked only in the memories of instruments and notebooks. When people talk about 3e Atlas and an old radio mystery in the same breath, what they are really doing is laying two marks on that map and asking whether they share a road or only the same broad region. The marks are small, but the idea that they might lie along a similar track has given many minds something to quietly walk around. Decades before this interstellar traveller appeared, a different kind of visitor brushed past our awareness. In the summer of 1977, a large radio telescope in Ohio listened to a fixed point in the sky as part of an early search for narrowband signals that might stand out from natural noise. For most of the observing run, the data looked like any other stretch of cosmic background, a steady stream of numbers printed on long sheets of paper. Then, during one brief window, a set of values suddenly rose far above the rest, forming a narrow, strong signal at a frequency close to the natural emission line of hydrogen. When a researcher later scanned the printout, he circled that cluster and wrote a short exclamation in the margin, a single word that became the name of the event. That radio flash, lasting only about a minute, has never been repeated from the same direction with the same characteristics. It was confined to a narrow slice of spectrum, did not obviously match any known type of interference, and arrived from a region of the sky not associated with a bright local source. Over the years, many explanations have been suggested. A natural but rare phenomenon, an unknown kind of interference, a glitch in the equipment, or, more boldly, a hint of artificial transmission from somewhere along that line of sight. None has been confirmed, and the event remains a solitary marker on the map, a single footprint on a road we haven't seen again. Now the path of 3e Atlas comes into the story. When researchers traced its incoming direction back across the celestial sphere, they found that it approached from a part of the sky, not far from where that old radio signal seemed to originate. The separation is on the order of several degrees, wide enough that you could easily fit many full moons between the two positions, yet close enough that they share the same broad quadrant on our star chart. Along with that angular proximity, there is the matter of frequency. The hydroxyl absorption lines detected from the object sit in a band of radio spectrum neighboring the same hydrogen region that early searches for extraterrestrial transmissions have favored. On the map of frequencies and directions that radio astronomers carry in their minds, these are nearby lanes, if not the same strip of pavement. It is easy, when you hear this, to imagine a straight road. You might picture the old signal as a signpost at one end, and 3i Atlas as a vehicle passing near the other end after a very long journey. The human brain is good at drawing lines between points, at telling itself that when two marks are close in angle and theme, they must share a story. From a scientific perspective, though, closeness on the sky does not guarantee cloneness in space, and similarity in frequency does not guarantee a shared cause. The galaxy is spacious. Many unrelated travelers can seem to pass along the same projected route when seen from our single vantage point. Still, the coincidence is interesting enough to earn a note in the margins of professional papers and quiet conversations. The sky region in question has long been considered a reasonable place to listen, simply because it lies in a useful band of the Milky Way where many stars reside. The hydrogen frequency and its neighbours are practical listening posts too, crowded with natural emission but also attractive as a kind of universal hailing channel that many SETI strategies have considered. That means both the old signal and the new object are, in some ways, products of choices. Choices about where to point dishes, and choices about which spectral highways we watch most closely. When you spend a lot of your time driving along certain roads, it is not surprising that several of your most memorable events occur somewhere along them. For those who are hopeful about finding company in the cosmos, it is tempting to see 3I Atlas as another traveller on that same road, perhaps even related to the source of the earlier radio footprint. For those who are cautious, the overlap is more likely treated as a reminder that interesting things can cluster in places where our attention is already focused. The journey of understanding lies between these two attitudes. On one side, an eagerness to connect dots and declare a shared origin. On the other, a discipline that insists on more than a proximity before drawing a solid line between waypoints. Science moves forward by letting the map include both the dots and the uncertainty about the routes that link them. If, someday, multiple interstellar objects were found to arrive from nearly the same three-dimensional direction, carrying consistent, unusual signatures, in both their motions and their emissions, the map would begin to look different. A repeated lane through space, with several travellers sharing it, would invite deeper questions about whether we are seeing the random scatter of debris or a more organised stream of visitors. Right now, though, we have a single object and a single old radio event, both intriguing, both isolated, both occupying approximately the same neighbourhood in our charts. That is enough to motivate careful study and imaginative hypotheses. It is not yet enough to claim that they share a common source, only that they lie along a similar projected road in our view of the sky. As you lie there listening, it may help to think of the galaxy as a network of routes that we are only beginning to trace. Some roads are carved by gravity alone, paths of comets, stars, and gas clouds that follow the general flow of the disk. Other potential roads are only ideas for now, imagined lanes along which a technological civilization might send signals or probes. Our task is to walk along the actual data we have, marking the crossroads where something strange happened, noting the directions, the frequencies, the times, and leaving space in the notebook for whatever future travellers we may notice along the same general way. Far above you, 3I Atlas continues its own long crossing, carrying whatever history it holds through our small corner of the Milky Way. Behind us in time, that minute-long radio event still glows as a single dot on the timeline, a brief flare on the route we once watched from Ohio. Between them stretches the broad road of possibility, still mostly unlit, calm and quiet, waiting for more footprints. As you drift towards sleep, the sky outside your walls can be imagined not as a puzzle to be solved tonight, but as a vast, blue-tinged horizon of journeys whose full maps will belong to many generations of observers, not just to us. There is a different kind of tension that comes when a date is circled on the calendar, not the sharp kind that knots your stomach, but the soft kind that simply waits. For 3i Atlas, that circle sits over a day in December, when the visitor will draw as close to Earth as its path allows before sailing away again. Astronomers have written that moment into their schedules, lined up instruments, and tested software. But the feeling underneath all that preparation is surprisingly quiet. Nothing about this approach looks like a threat. Instead, it feels like watching a distant ship slide along the horizon of a safe harbour, close enough to study its lines, far enough that no course correction is needed on our shore. Predictions say the object will pass at a distance roughly comparable to the stretch between Earth and Sun, a wide black channel of space where nothing brushes directly past our planet. From a human point of view, that is unimaginably far, a gap so large that you could stack the orbits of many worlds inside it. From an astronomical point of view, it is close enough to offer excellent views, a chance for even modest telescopes to pull the traveller out of the background glitter. In that paradox lies the quiet beauty of this flyby, distant enough to be safe, near enough to be personal. Step by step, as the date approaches, the object's apparent brightness will change. Light from the sun will still be the only lamp, bouncing off dust and gas around the nucleus, and then travelling down to our detectors. Because the geometry between sun, object, and Earth will shift day by day, the way that light spreads and scatters will change too. Models predict a gentle rise in brightness as the distance shrinks, perhaps a soft peak if activity remains steady, followed by a fading as the ship continues along its outbound leg. Plotted on a graph, that slow swell and decline forms what observers call a light curve, but you can think of it as the visible wake of a vessel moving across the dark water of space. Professional observatories will track that curve with precise instruments, but they will not be alone. Amateur astronomers around the world are already noting the coordinates, planning to swing their backyard telescopes toward the predicted position. Some will use cooled cameras and careful stacking to tease every last photon out of the night. Others will simply enjoy the fact that they are watching a visitor from another system with equipment that fits in the trunk of a car. Together, their observations will add more dots to the shared chart, confirming where the object is, how bright it appears, and how its tail and jets look under different skies. In that sense, the harbour lights of Earth will be watching the passing ship from many piers at once. Each new data point will be checked against the expected path. If 3i Atlas behaves like a natural comet, with the quirks we have already seen, its motion will follow the updated curves computed from gravity and known outgassing forces. Small deviations may still appear as new activity wakes or quiets, but those will be within the range of what our models can adjust for over time. If, against expectation, the trajectory were to shift sharply without visible cause, that anomaly would stand out immediately when positions from different nights were compared. The fact that thousands of eyes, both professional and amateur, will be watching makes it unlikely that any major surprise could slip past unnoticed. Beyond position and brightness, the December pass offers a chance to refine our understanding of the nucleus itself. By measuring how the light flickers as the object rotates, observers can strengthen estimates of its spin period and shape. A more elongated body will produce a more pronounced rise and fall in brightness each turn, like a ship whose broadside and narrow bow reflect very different amounts of light to a distant watcher. A more compact, rounded body will change more subtly, with only gentle variations as it spins beneath its luminous halo. Those details help us decide whether Three-Eye Atlas belongs among the stranger, cigar-shaped visitors of the past, or among the more ordinary lumpy stones that drift between the stars. Spectrographs will also be pointed at the traveller, even from smaller observatories. They will look for the familiar fingers of different gases and dust signatures, comparing December's mix with what was seen around perihelion. If the same blue-green cloak persists, that suggests ongoing production of the same molecules and particle sizes. If the hues drift back toward warmer tones, it may mean certain volatile stores have already been spent. Either way, the change, or lack of change, will be another line in the logbook, another subtle clue about the engines of chemistry and sunlight working in the coma. None of this will change the object's safe distance. It will simply let us read more of its story while it is briefly close enough for many instruments to listen. Some people have wondered whether the flyby might trigger some dramatic reveal, as if the ship would choose that moment to signal or alter course. From a scientific standpoint, there is no special mechanism that connects proximity to Earth with any expected change in behavior. Gravity doesn't suddenly spike at this distance, and no hidden beam or net waits to be crossed. If any significant adjustment were to happen, it would most likely be tied to internal processes or to the object's changing relationship with the Sun, not to our planet in particular. The flyby is a test only in the sense that it provides a clearer view of whether ongoing small accelerations match the picture painted by previous data. For you, trying to rest, it might help to imagine that night in the simplest way. A winter sky, perhaps, clear enough that stars are sharp and steady. A few observatories humming quietly on distant hills. A handful of backyard astronomers bundled in jackets, breath-misting as they check focus and exposure. Far above them all, the ship from another system slips through its plotted lane, gliding past our harbour lights without turning in. On screens and in eyepieces, it appears as a faint smudge or a tiny streak, more suggestion than spectacle. Yet, in the shared awareness of those watching, it becomes a gentle reminder that our small world sits beside a deep channel where such travellers can pass untroubled. When the night of closest approach is over, measurements will be saved, light curves extended, error bars tightened. Reports will follow in their own time, some technical, some written for a wider audience, each one another small lantern along the path of understanding. The object itself will already be farther away, the angle between it and our sun slowly widening, like a ship's lantern sinking lower toward the horizon as it heads back out to sea. Doors of control rooms will close with soft clicks. Latches engaging as staff go home to their own quiet rooms and ordinary concerns. In that stillness, the circled date on the calendar can be left behind, the test quietly completed, while you let your own thoughts ease shut like a door that has found its resting place in the frame. If I could write you a letter tonight instead of speaking in your ear, I think I would begin with a very small image. A single lamp on a desk, turned low, spilling just enough light to see the page. Outside the window, the world of headlines and arguments would be fading, but in that pool of light, there would still be room for a slower kind of thinking. The kind that science needs when things feel both exciting and uncertain. This whole story of 3E Atlas belongs in that small circle of light, as much as it belongs on big screens and noisy feeds. You have probably noticed how quickly the word alien appears whenever an object behaves strangely. Some people reach for it like a bright flashlight, snapping it on at the first shadow. Others flinch away and insist the lamp must stay pointed only at familiar explanations. Between those two reactions sits the quieter beam of the scientific method, asking for just enough illumination to see the facts clearly without burning away every mystery. When one well-known astronomer refused to rule out exotic possibilities too early, he found himself standing in a rather harsh glare, accused of chasing attention simply by leaving the door a little open. In interviews, he kept returning to the same simple point. It is not irresponsible to admit you do not know. It is irresponsible to pretend you do. Something gentle happened in response to that stance. Letters and messages began to arrive from people scattered all over the world, not angry, but grateful. A teacher in Italy thanking him for speaking plainly with his students in mind. A creator in South Africa offering to help explain the data to more viewers. An artist in Kenya sending a note about how comforting it was to see someone admit uncertainty without turning off the light of curiosity. Others from Mexico, from the United Kingdom, from Florida and beyond, all saying in their own words, "Thank you for keeping the lamp steady instead of swinging it wildly." Those messages do not prove anything about 3I Atlas itself, but they reveal something about us. People are not only hungry for spectacular answers, they are hungry for honest questions, for a way of talking about the unknown that neither dismisses it nor inflates it. They want to be treated as partners standing around the same small lamp, not as a crowd to be dazzled or soothed from a distance. In that sense, this interstellar visitor is already doing a kind of quiet work in the human mind, teaching us how to sit with ambiguity without turning everything into either a horror story or a shrug. The object may be made of dust, ice, and metal, but the way we respond to it is made of trust, patience, and the willingness to let the light be soft. This is not our first encounter with a traveller from beyond the sun's family. Years ago, another elongated visitor swept through on a steeper path, leaving behind its own trail of questions about shape and unexplained acceleration. Soon after, a second interstellar comet arrived, more comfortably comet-like, with a behaviour that reassured those who prefer tidy categories. Now 3I Atlas adds its signature to that growing sequence, neither a perfect repeat of the first, nor a simple copy of the second. You can almost feel the light on our cosmic map getting a little brighter with each new mark. The lamp of understanding turned up one small notch at a time. With every visitor, our tools and our thinking improve. Protocols are drafted for how to respond if something truly extraordinary ever appears, how to check instruments, how to coordinate between observatories, how to share data openly and quickly. Philosophers, ethicists and policymakers join the conversation, asking how we might handle the news if a clear techno-signature were ever confirmed. We do not have that confirmation now. 3i Atlas has offered only suggestive shadows and unusual behavior, nothing that forces us to declare that someone lit it on purpose. Yet, by learning how to talk about that possibility without either panic or ridicule, we are quietly preparing the room for whatever future light may come. In your own life, there is probably a smaller version of this same pattern. You encounter things that do not fit your current models, odd results, unexpected feelings, sudden turns in plans. Part of you wants to flood them with a harsh, quick explanation, anything to get rid of the darkness. Another part may want to look away and pretend nothing has changed. The skill is in doing what astronomers try to do on their best nights. Widen the circle of the lamp just enough to gather good information, speak honestly about what you see, and leave some edges for later. The story of 3e Atlas can become a gentle metaphor for that skill, a way of remembering that not knowing is a doorway, not a failure. One day, generations from now, students may read about this object in a paragraph or two, the way we now read about early discoveries that seemed enormous to their own era. They may smile at our arguments, at the way we wrestled with jets and colours and tiny shifts in orbit, all under the limited lamp of our present instruments. By their time, perhaps dozens or hundreds of interstellar visitors will have been catalogued, their properties mapped with clarity we can only imagine. Maybe one of them will carry a signature so unambiguous that no one will doubt it was crafted, not grown. Or maybe all of them will turn out to be beautiful, stubbornly natural pieces of a universe that needs no extra maker of probes to be astonishing. Tonight, though, you do not have to solve that future. You only have to decide how you want to sit with the light you have. You can picture the small lamp on the desk again, its circle of warmth just big enough for a notebook, a cooling mug, and your resting hands. In that pool of light, the words on the page do not shout. They simply say, "We are still learning," and that is all right. Beyond the window, 3e Atlas moves on, its own faint glow folded into the larger darkness, while down here the envelope of this day is almost ready to close softly around you. Late in the story of an object like this, the nights in the lab take on a special kind of stillness. Monitors dimmed, hallway lights on motion sensors, just a few islands of glow left where the last plots are open. I imagine myself at one of those desks, a mug cooling beside the keyboard, the building mostly asleep except for a handful of people, and the faint, always present hum of equipment. On the main screen in front of me, 3i Atlas is no longer diving past the sun or threading near Earth. It is on the long, outbound leg, now, heading toward one last bright encounter in our system before the dark swallows it again. That final meeting is with Jupiter, the biggest lamp in our local sky after the sun itself. The predicted pass will not be a close shave, more like a distant handshake at tens of millions of kilometers. From Jupiter's perspective, the visitor will be just another small object drifting through its broad sphere of influence, skimming past the outskirts of the giant planet's gravity well. Yet, that encounter matters, because Jupiter is more than a bright dot. It is a massive lens that can gently target trajectories and a convenient spotlight for instruments already orbiting nearby. One of those instruments, riding aboard a spacecraft that has spent years exploring Jupiter's storms and magnetic fields, has been asked to look outward for a while, turning its sensors toward the passing shard from another star. In the quiet of the night shift, I picture those commands already queued, waiting for their turn to wake the cameras. If additional outgassing is still happening by then, the giant planet's pull and the changing geometry of sunlight could draw more activity out of the nucleus. Cracks that only half opened near the sun might widen a little further under new stresses. Trapped pockets of volatile material might find fresh paths to the surface. From far away, any such changes would appear as tiny tweaks in the path, little shifts that careful orbit fits would need to absorb. From the vantage of the instruments near Jupiter, they would show up as subtle differences in brightness, jet structure, or gas signatures, one more set of hints about how this tough, ancient body responds to different kinds of light. No single measurement will transform our understanding, but each one adds a small candle to the row. It is possible, of course, that by the time 3I Atlas glides past Jupiter, most of its easily accessible volatiles will already have been spent. In that case, the encounter will be quieter still, a mostly dormant nucleus sliding through the outer beams of sunlight with only a thin, fading halo. The instruments will look anyway, because even a null result is a kind of answer. If little or no extra acceleration appears, if no fresh jets bloom under the planet's influence, that absence will tighten the limits on how much hidden power remains inside the traveller. The chart of its journey will gain one more point of light, confirming that the main chapter of activity truly belonged to its time near the Sun. Beyond Jupiter, the path grows emptier. The Sun shrinks in the rearview mirror from a blinding lamp to a bright star, then slowly to something more ordinary, as distance smooths out its intensity. Whatever jets still flicker from 3E Atlas will fade as the surface cools, the coma thinning until even our largest telescopes can no longer pick out a distinct glow. Gravity will continue to guide it, but the guiding will be gentle now. The long, slow arc back into the interstellar mist from which it came. In a sense, our entire solar system was just one brilliantly lit hallway along its route, and it will spend far more time in the dark rooms on either side than it ever did under our lamps. Back in the lab, long after the object has slipped beyond the reach of direct observations, the true legacy of its visit will live in the data that remains. Stacks of images documenting changing jets and colors, radio spectra with their narrow dips where hydroxyl once bit into the background. Astrometric records tracking each tiny drift from a gravity-only path. Together, they will form a kind of light curve of understanding, rising from confusion to clarity in small steps as models improve and comparisons with other interstellar visitors accumulate. The quirks that seemed so dramatic at first will be reclassified as one flavor in a growing menu of behaviors, each one illuminated by better statistics and deeper theory. Some hypotheses will have dimmed to almost nothing by then. Others will still glow softly, awaiting the next object that might brighten or extinguish them. What 3I Atlas has already taught us is not just about itself, but about how we respond when the universe hands us something that does not fit neatly under the usual lamps. We learned how easily our attention jumps to the brightest, most exotic explanations, and how important it is to keep the softer light of patience turned on beside them. We saw agencies reminded that transparency is its own kind of illumination, that withholding images creates shadows where speculation thrives. We watch scientists model outgassing, composition, and trajectories with increasing care, proving that natural mechanisms can stretch further than we once assumed without needing any secret engines hidden in the dark. And we practiced, as a global community, the art of looking up together, letting many small beams of observation overlap instead of waiting for a single spotlight from a single stage. There is also something more personal in this legacy. To know that a fragment older than our sun has passed through our sky is to feel our own lives lit from a different angle for a moment. The worries that fill a given week look smaller under that kind of illumination, their edges softened by the awareness that we are part of a story running on billion-year timers. We are reminded that curiosity itself is like a pilot flame, small but persistent, ready to ignite brighter bursts of discovery when the fuel of data arrives. 3i Atlas did not need to be a probe or a beacon to play that role. It only needed to be itself, strange enough to make us look again, steady enough to let us learn. As my imagined night shift comes to an end, I picture someone walking slowly down the corridor of the observatory, checking that the main lights are off and the essential ones are on. Labs darken one by one, their screens slipping into sleep, leaving only a few indicators glowing on. Power strips and instrument racks. Those tiny dots of green and amber are not there to flood the room with brightness. They are there to say, quietly, I am still here. I am still watching. Outside, above the roofline, the real sky carries its own soft constellation of steady lights, stars and planets shining with no switches at all. And somewhere out beyond Jupiter's orbit, the interstellar traveler moves on through that wide darkness, no longer under our lamps, but forever, part of the faint, shared glow of what we have come to know. As we come to the end of this long, quiet watch together, I like to gather the simplest things we actually know and lay them out like small stones on a table. An object from another star system, 3i Atlas, entered our sky. We saw it follow a safe path past the sun and onward toward the outer system, its orbit measured again and again by telescopes on the ground and in space. We watched it wake up late, releasing gas and dust only near perihelion, when the sun's heat finally bit deep enough into its hardened surface. Radio instruments caught narrow hydroxyl lines at specific frequencies, telling us that water molecules were being broken apart and lifted into space. Optical observatories saw its color change from a dusty red to a striking blue-green, evidence that finer particles and glowing gases had joined the coma. Images revealed a complex pattern of jets, not just one tail, but multiple streams of material fanning out in different directions, some aligned with sunlight, some less obviously so. Careful tracking showed that its path drifted slightly from a purely gravitational curve, a non-gravitational acceleration that we know can come from outgassing, even when the visible coma looks modest. Through all of this, its distance from Earth remained comfortably large. Every refined calculation confirmed that it was a visitor, not a threat. We saw agencies speak, critics respond, letters of concern and gratitude arrive, and a global mesh of professional and amateur observers quietly add their own dots to the shared chart. Now the traveler is on its outbound leg, heading toward a final, distant brush with Jupiter, and then back into the wider darkness between stars. The data it left behind will keep teaching us for many years. Tonight, it only needs to help you rest. You have walked with me through these 12 gentle chapters, from first detection to fading halo. Let the story close its eyes now, like a console screen dimming after a long shift, and let your own breathing become the only soft signal in the room.